And welcome to TIA Now's post-coverage of TIA's CTO Council meeting for 2015. We talked about a number of topics, primarily the Internet of Things, but also a little bit of NFV and 5G as well. I want to introduce our panelists for this post-show program. We have Tim Abels on the end with Intel. Next to him is Manish Jindal with Ericsson. Next to Manish is Bruno Rijsman with Juniper. And next to me is Drew Schulke with Dell. And Drew, you were kind enough, and your company was kind enough to sponsor not only this event, but this panel as well. So we appreciate that.
You're welcome.
Thank you very much. I'm going to go all the way to the end of the line here and start with Tim Abels. I want to talk to you about carrier class networks and the importance of standards for that network. There was I guess a number of areas or a number of points made during the meeting just earlier about the importance of standards, but also about the migration towards open source standards and why that's moving much faster than, I guess, the legacy way of standardization. How do you reconcile those contradictions?
Good question. So, IoT and telephony in general is now combining two very different groups of developers. You've got the embedded, high quality 5 nines, 6 nines, they understand that. But now for the first time, we're bringing in mobile and many other developers that are very rapid, very fast. And so the chemistry here is we're combining two very different things. And these are some of the most extreme to say very few software packages, OSs and such have this high quality that is going to be essential for IoT libraries, IoT platforms, and success of IoT. You must have low latency, security, 5 nines and such. Open source, to get things out there early, to get feedback from folks, you really want both. Someday, if we can get together some kind of TIA test bed or something like that, we're going to need to win over both developers, both extremes, by saying here's a lot of open source, but here's also very high quality. It's worth your time.
Manish, I want to ask you about, again, the success of the open source standards community right now. Is it because they focus on particular verticals or solutions? Is that why they're successful, or perceived that way anyway?
Well, in terms of, they're definitely successful in getting things out much faster. Right, so if you look at the telecom industry, it takes 3 to 4 years to standardize something. And it's just because of the sheer complexity and, like Tim said, in terms of the robustness that is required. So we need to look at every aspect of it. Different companies need to come together to agree on a standard. You look at the open source, it's a company that came to the market first, they implement something, and then the rest of the organization and the industry kind of drives behind it, improving it, making changes to it to their own needs, and then it kind of becomes an open source where everyone else can meet, and it's free. And whereas on the other side, where the standardization takes 3 or 4 years, it's the harmonization of all the vendors coming in to sort of create a much bigger model, the 5 nines as you were looking at.
Bruno, just to pick off from where Manish left off, can we all agree that there's not going to be an overriding primary IoT standard, but maybe a dedicated standard for different verticals, whether it be automotive, industrial, or health IT? But on the other side of that coin, should there be 1 or 2 primary IoT standards that we can build off of?
Well, one of the interesting things about IoT is that there's such an enormous range of use cases. There's applications in the consumer space, there's applications in the automotive space, there's applications in the industrial space, and correspondingly, there will be a huge range of technologies to generate the telemetry from the IoT endpoints into the network. But at some point in the network, there will be a point where all of this data is aggregated and normalized, for example, an IoT gateway. So what we as a networking vendor concentrate on is what is common across all of these use cases? How does it affect the architecture of the network, rather than concentrating on the specifics of one particular access technology? So we look at how to deal with the large scale of endpoint devices. We look at how to deal with the enormous volume of analytics telemetry. And some of the new architectures in the network that we are working on to address these kinds of things is to push the processing of the information further out to the edge of the network using concepts such as fog computing or mist computing.
Drew, I want to shift just for a brief moment to virtual networking. During the CTO Council meeting just earlier, in referring to next generation infrastructures, next generation data centers, You called NFV the telco cloud. Why is that?
Well, I think what we're trying to say there is the underpinnings of NFV is a cloud. But if we only design our clouds to work for an NFV use case, we've really sold ourselves short. In terms of carriers and telcos, as they're putting the infrastructure in place to enable things like NFV, we need to think broader about the use cases and the opportunities that will appear in the next 5 to 7 years. And if we put in a cloud infrastructure, or a platform as we call it, for the carriers and the telcos that isn't flexible and agile enough to move beyond NFV, then we've really failed. And it's about really taking the lessons learned from the enterprise in terms of putting in a robust, capable solution that can handle multiple use cases, and that's really what our goal is. NFV is certainly a very a priority for us, and a lot of our customers are anxious to get there. But at the same time, we know NFV is just the beginning. There's a lot more coming as the networks become more virtualized.
Tim, go ahead, Bruno.
Can I add something to that? Everyone is familiar with the public clouds that Amazon and Google and those players are building. We're also familiar with private clouds, but there's truly something different about the telco clouds that the service providers are building for network function virtualization. For example, they're not huge centralized pools of resources. These are much more distributed small data centers. So there needs to be intelligence about where to host the virtual network functions. Another example is that in telco cloud, unlike public cloud and private cloud, data plane throughput is extremely important. So now you start looking at things such as SRIOV and DPDK, and these are techniques that are typically not used in other types of cloud. So telco cloud is truly a different type of cloud for the telcos that has unique requirements.
I think and to build on that, Bruno, when you look at the cloud execution environment, in terms of, if you look at hypervisors, the OpenStacks and VMware, they were built for the IT cloud. They were built for the typical data centers, but then they lacked the requirements for 5 nines. They lacked some of the telecom requirements. And what the industry is doing is they've taken, again, as we were talking about open source, they've taken the OpenStacks of the world and they've actually made some improvements to it so that we can make it telco grade. So then when you're talking about NFV and all the VNFs on top of that, like let's take the case of IMS or virtual EPC, these cloud environments have been hardened so that we can create the 5 nines, we can create geo-redundancies, we can create some anti-affinity models, etc. So that's going to harden them and actually bring the telco world and take advantages of what the IT world brought to the data centers.
Tim, there's a number of various IoT use cases. There's a number of standards architectures that support those use cases in IoT. How do you figure out how to parse through all these architectures?
So good question. So if you looked at it at the highest level, they really are vertical specific to medical, to automotive and such. But if you look at it, what you heard about, data plane developer kit and things like that, it's heavily the data. It's the end-to-end data. And so you can look at what is the main pattern for your inputs, outputs. This is a queuing. It's smart parking. What are the main sensors and the data that they're creating? This is a camera sensor. And so when you start to actually look at the patterns of the highest level compute and then the data from the sensors, you can quickly narrow down common cases that are flowing through these. So as we resolve these patterns and very reusable workloads in telecom industry, we'll be able to handle common features across, surprisingly, verticals. So what is also like a control system, like a smart meter? And what's the pressure sensor on that? We can find use cases just like that aren't close to that field. And so this is why we'll be able to really tune the hardware, the data packetizing, all of the networking there in an industry like telecom.
Manish, during the meeting, you talked about standardizing platforms. You said we need to get into the platform service rather than just the solution service in order to make device number 1 provide value to device number 2. Why did you focus so much on that point? Because you brought it up a couple times. Yeah,
so typically there are 2 ways of doing it. You can create a vertical ecosystems where we were talking about Nest as an example. So you could create a system where the whole solution is built around Nest only in terms of managing the temperature in the house, etc. However, if you take the case of car as another sensor, and you can actually take the data from one particular sensor and make use of that particular data from towards the other sensor, you're going to create a lot wider set of solutions over that. So what I'm looking at is abstracting the data from each of the different sensors towards the platform, building the analytics around it, and being able to create more and more solutions and applications on top of that. Let me give you an example. So if I'm approaching home from work, and so there's a sensor, the car sensor, that tells me exactly how far I am from home, what time would I reach home, etc. That information is all available. Now, at the same time, if that could be communicated to my Nest in my home to say, turn on cooling in my house 30 minutes before I arrive home. Now that could not happen if you didn't have a platform and if you had siloed solutions. And that's the reason why I was driving towards the platform as opposed to just a solo service provision.
Bruno, again in the meeting, you said one of the big challenges for Juniper right now in the IoT and NFV space was deploying a multi-vendor telco cloud with various levels of standardization. What's an example of this scenario?
Yeah, so if you look at what's been happening over the last 2 years or so, last year was the year where our customers were doing proof of concepts with NFV, and those were relatively constrained experiments with a single vendor. Now they're actually starting to deploy their telco clouds. They're actually building telco clouds as a general platform to host all of their virtual network functions. And now what we're seeing is that different products from different vendors are coming together. In practice, that turns out to be far more complicated than one would expect. It turns out to be really, really difficult to have equipment from one vendor, an orchestration layer from another vendor, and then virtual network functions from different vendors. So let me give a few concrete examples. Different vendors are doing their service chaining in different ways. Some people use OpenFlow, some people use overlays, some people use VLANs. So it's really difficult to create a service chain with virtual network functions from different vendors. Another example is once you've deployed a virtual firewall, you still have to push the service layer configuration into that. There's really no standard way of doing that. Some people use netconf, some people use CLI. There's many different methods. So it turns out that because there's a lack of standards, it's really, really difficult to build actual NFV real-life deployments, and standardization would help a lot there.
Yeah, and I just echo on that, which is I think what we've done here today and what TIA is trying to do would be a great step forward into trying to solve some of that, because we're seeing some of the similar experiences to Bruno out in the field, where the promise of NFV is huge in terms of the agility that it brings to organizations, but at the same time, we're all trying to get it up and running and stable at this point in time, and we know we're going to get there, but working together is going to be required to make it a very stable platform.
Now, just tailing off of what Bruno was talking about, big Web 2.0 companies have been doing that for years. What he explained, what makes telco different?
Yeah, great question. So two things pop to mind for me. One is if you look at the big Web 2.0 companies, typically they have the luxury of having a single monolithic application that they're working with. It's not this wide variety of use cases that they need to go off and support. So now that application is massive and it scales out tremendously, but it removes a lot of variables out of the equation. And the other piece would be around talking about carrier grade or telco grade and 5 nines and 6 nines. A lot of the Web 2.0 companies tend to be consumer oriented companies, and so while they want to have strong uptime and have a great customer experience, if your search engine doesn't return the next page of results, or your social media page goes down for a couple hours, it's not like a 911 network going down, right? So they had a couple of advantages in terms of kind of getting there and what they had to work with, as opposed to what we're trying to do in the carrier space.
Yeah, really, I mean, the whole concept of 5 nines or 6 nines came from the telco world, right? So as we move the NFV and cloud world, data center world towards the telco, I think at some point of time they will converge, but at least till then there's going to be a lot of these one-off situations where we'll have to, to your point, Bruno, we will have to make sure that they have proper standards to talk to each other. At the same time, the robustness of the solution and making sure that if you're providing the cloud solution to a critical infrastructure, that obviously you could not do on the fly. You will absolutely have to have very, very tight interfaces tied into working and making sure they test absolutely well.
Yeah, one of the interesting observations, since you compared it with the Web 2.0 players, is that in the telco space, what we tend to do is build a 5 nines infrastructure and then deploy an application on top of it. What the Web 2.0 folks are doing is they deploy a 3 nines infrastructure and they build the high reliability and the high availability into the application. If an entire rack would fail in a telco environment, people would freak out. If an entire rack fails in an Amazon data center, they don't even blink. The application takes over. And so it's a different way of thinking about things.
Tim, you said in IoT that the local office has to communicate or report really to the central office. I want to have you explain that dynamic to us, but does there need to be a hierarchy in the control layer? Is that where you were going with that?
Yes. So it's also generations. A first generation, just like today, where you can get out NFV, you can start putting out the nodes, so they'll have a forward proofing. And so we will have those soon, and vendors here at this booth here will have that. But the key is it's really a second generation. So the first generation is, think of it like local government. You can have root of trust, chain of trust in the node itself. But then when you get to software defined, you can't have node defined and software defined. It has to be control from top down. And it's at that time where the only rights that the node has is what rights are given it by central. And so there'll be a hierarchy of control. They will have to have the ultimate control over service levels, guarantees, quality of service, and a node will have rights for a little while as granted. Do a firmware update. Update 2 million GM vehicles. But it's a brief permission for a brief time because there'll be the hierarchy of control coming down, and that's central government, if you will, or central office. And then there'll be the local office where you only get the rights for a brief time that were given to you. So that's truly software defined. Otherwise, software really isn't programming and controlling.
Manish, I want to talk again briefly about the economics of IoT. And again, this was brought up a couple times during the discussion, and you're welcome to expand on further on that discussion if you'd like. I want to talk about, or the question for you really is, what are the forces that are driving the price of IoT devices down, i.e., let's say sensors?
Yeah. So one of the things is, as we're looking at from 2020, we're looking at about 26 billion devices and eventually up to 50 billion devices. Now, in order for that economics to work, the devices have to be sub $10. Now, we do foresee these devices are going to be, their battery lives need to last for about 10 years, right? And these are not devices that are going to be very chatty. And by definition, for the battery life to be lasting for 10 years, the communication has to be only when some information needs to be received or sent. So one of the ways of reducing the cost of these devices is making sure they have very cheap modules where the data rates that they need to receive and send is very, very low. They're not looking at as your regular smartphones of hundreds of megabytes of data. They're looking at very, very low data. So by doing that, by having these modules that need very low capacity data, they're not very chatty. That's one of the ways of driving the cost down. The other piece of it is going to be the economics in terms of scale. So if we have lots and lots of these, automatically due to the scale, the price of these things will continue to go down, and that's the only way we can have an economic model that will work with billions and billions of devices.
So some first hop devices will be high quality, medical, aerospace. So we'll have to be above that $3. But if the second hop can, there's RPL, there's many standards out there that allow the first hop to be very forgiving. And so you can really go with high volume, low cost, and this is how there'll be so many IoT sensor devices out there, is the vast majority can be in that category as long as the second hop in the wide area can still be telco grade.
Bruno, I want to go to you on security, IoT security. You can't secure all data with a centralized model, really. You can't secure all data with a local model. Is a distributed architecture the way to go?
Yeah, as you point out, security is typically addressed either at the endpoint, which is not feasible because these devices need to be extremely low cost and they can't be intelligent and powerful enough to host a local security function, or it is applied centrally. For example, in the GI LAN, in a wireless network, in a mobile network. with a multi-terabit firewall. And that model also doesn't work anymore because we will have such a large volume of very short-lived sessions that it's not very ideal for that kind of model. So what you will end up with is a much more hierarchical model where the security is spread out across different locations in the network. Some very simple functions might be performed at the endpoint, some functions might be performed at the IoT gateway, and other functions might be provided at different layers in the network. And what is actually happening is that the distinction between compute and networking, the distinction between servers and switches, is slowly becoming more vague. Obviously, we're deploying virtual network functions on servers, but we're also having the ability to put containers and virtual machines on networking equipment as it is shipping today. And that allows you to push some of the compute, including security and including analytics, closer to the edge of the network and to distribute it across various locations in the network.
Drew, certainly service providers, operators have a interesting road ahead to maybe change the perception of their dumb pipe into a smart pipe. What's your perception of the operator's pipe? Is it becoming smarter?
Well, I think based upon some of the two previous questions, if you think about what we talked about there, the answer is it almost has to be, right? The economics that Manish talked about, 26 billion devices, going to 50 billion devices, the cost pressure on those, the smarts can't sit out at the device level, right? At the same time, doing so at a central control with sort of Big Brother having all the smarts centralized, again, technically is going to pose challenges. It's the same security dilemma that we have. And that leaves one place for the smarts to go live, and that is in the pipes. So I think the short answer is yeah, and that's going to be a huge portion of this shift in this industry as we see to a very, very different model going forward. But it's a huge opportunity for the service providers, without a doubt.
The service providers are the perfect fit for, if you think of the endpoints of the pipe, and then to have some kind of contract. So go to some cloud broker and say, I want to guarantee these service levels for this pipe for this time frame. And as long as there's the hooks at both ends, this is what they've done, this is what they'll continue to do. It takes very few hooks then to add very high quality to all that metadata and data going through that pipe.
The networks today, and let's talk about the wireless networks, the amount of data these networks have is just tremendous. And if you look at, who do the end users actually trust today, and we were talking about security, right? The number one is the banks, and number two is the telecom industry. Those are the two industries that the end users actually do trust, right? And the amount of data that comes from these networks today, if you were to monetize these and be able to use analytics on these, there's a lot of valuable data that comes from networks, and that's one of the reasons that I agree that they're going to be far from just being bit pipes.
It was an interesting conversation earlier during the CTO Council meeting for 2015. Again, we talked about IoT again in this panel. We talked about it primarily, but there was some talk about virtual networking as well and a bit about 5G. I want to thank all four of you for staying behind and being with us on this panel. Tim, it was nice meeting you, and thanks for joining us. Your knowledge base is a pleasure to listen to. Manish, thanks for being with us. Bruno, it's nice meeting you. And Drew, again, thanks for sponsoring not only the CTO Council meeting, but also the panel that we're on.
Absolutely, pleasure.
Appreciate it. And for more coverage of TI Now here in Austin, Texas, you can follow us tomorrow at Dell World. So long.